This is problem 5 of chapter 27, continuing to look at linear regression and hypotheses testing as a means to strengthen our confidence about a linear model. So here we're looking at data, and this is a little bit tricky. This data, you have to really kind of pay attention. Here we're looking at a difference. See, that's the difference between men and women in terms of the age that they get married. Okay, so we have positive numbers, so it looks like men typically are getting married at an age that's older than women. We also have to, I believe that these are probably averages, right, for each year. The only way to get one data point is to look at an average, so we're subtracting averages. So that's something to kind of factor in to your thinking. So the first question is write a hypotheses test. So what we want to do is, I guess, sort of answer the question. We want to examine the regression to see if this difference is decreasing. In other words, maybe the ages that they're getting closer together, right? It's kind of getting closer to 0. So let's say something like this. First, we want to say that there's no change. So the difference in age between men and women at first marriage okay, so that's important. We're not talking about, you know, the 5th marriage or the 10th marriage. We're talking about the first marriage. At first marriage has not been decreasing, or let's just see has, I would say, has not changed. Or, well, I guess not. The difference has not been decreasing. It's probably more accurate. Okay, so the slope would be 0. Okay, and so the alternative would be the difference and the difference has been decreasing. Okay, so the slope of the line for the entire population is less than, right? We don't want to say not equal to, we want to say less than 0. So it's going down. That's what we're going to hypothesize, is that it's going down. Okay? Okay, which means females are starting to get married maybe at an older age, or males are starting to marry at a younger age. I don't know, but something explains the difference. Okay, so the next thing is, here are the residual plot and histogram. Really? They give us the residual plot? Okay, so here's the residual plot. So what and the residuals histogram. So let's just say I put a line, or we put a line through. We calculated a model. In fact, we did. Here's the data. Okay, so we put this line through, and we get all these residuals, right? Some are negative and some are positive. Okay, so there's a couple ways to display them. One is with a histogram, and what we'd like to see is a model that's unimodal and symmetric. So we do have a little bit of an issue, okay, right here. And then the other way we look at them is we kind of think of it, we put a line through here. This is 0. Okay, and then we want to look at to see if there's a pattern. And doesn't look like we really see a pattern. I'm concerned when my eye sees a little bit of a curvature like that. Okay, so I was a little concerned at first. But the residual plot doesn't, it shows a little bit of a, but we still do have a point on this side. It'd be nicer to have a point right there, obviously. But it doesn't show a significant pattern. Okay, so I said to not really be overly concerned with the conditions right now, but I wanted to share at least that part with you since they provided the data. So we'll go over this in more detail, but for now let's just say that the conditions are met. So we will proceed with and then what we're going to call is a regression t-test and the computer printout tells us 22 degrees of freedom. Alright, so for now that's good enough. And then I guess C is test the hypotheses and state your conclusion. Alright, so our model is that the center is at 0, okay, and our line, our equation up here that we put through is that the difference is equal to 49.902 minus 0.024. It's right here. Okay, times the year. So that's our model. So our test statistic is negative 0.024. So that's a pretty small number. It looks pretty close to 0, but without having the t-value, we really don't know if it's close to 0 or not. Okay, so the t-value is b, the observed value minus the expected value divided by the standard error of, I don't know why I keep putting bars out of habit. Okay, so it's going to be the standard error of b, so standard error of, so we get b, trying to go too fast, negative 0.024 minus 0, right? Divided by the standard error. So here's the standard error for the slope. So it's 0.0055. So even though this looked kind of close to 0, right? 0.024 seems like pretty close to 0. But when you divide by an extremely small number like this, we get a big number. So we get negative 4.35. I guess that's big for me. 1, 2, 3, 4. So we're way out here. We're right about there. Okay, so a long ways away from the hypothesized value. Okay, so the p-value is equal to the probability, and it's a one-tailed test, t less than minus 4.35, and we can pick that up right from the computer printout, 0.0003. So the p-value is small, so we reject the null hypotheses. There is sufficient evidence. What do you want to say here? There's sufficient evidence that, this is where we want to be careful, that the difference, so you can always go back up here, the difference in age between men and women at first marriage, that the difference in age between men and women at first marriage is decreasing. Okay? So that's all we can say. We can't really say by how much without computing a confidence interval. So that's coming next. But the confidence interval, as you know, is an estimate plus or minus the margin of error. Well, the estimate is just B. Why did I write a D? Is B. Okay? So plus or minus, the margin of error is going to be your t value, and df, times the standard error of B. So here's the good news. The good news is we know it. We can find it pretty easily. So B was negative 0.024 plus or minus this value here is going to be inverse t of, let's say we want a 95% confidence interval, so 0.205, and the degrees of freedom, what's the degrees of freedom? 22. Okay, we could say absolute value if you wanted. And then times the standard error, well, we already have that. It was 0.0055. 0.0055. So it's not that hard to compute the confidence interval. And so that would all that does is sort of kind of put a little bit of a range around the slope. The slope might be a little bit less, at times a little bit less negative, maybe sometimes a little bit more negative. So there is a range for that we would want to specify. Okay, that's the answer to that problem.